All right, so what we're working on is what's called end behavior in rational functions. Okay, so what we're going to do right now is I'd like you guys to simply, right here, this is the parent function. That's the parent function for all rational functions. So we call end behavior things that are going towards, we call it left end behavior. And over here on the right hand side, we call it right end behavior. So when you're going towards the left, where are my x values traveling, going this direction? Where are they going towards? They're going towards this concept called negative infinity. And on the right-hand side, where are my x values always traveling? To positive infinity. Okay, so x will always be going to positive infinity as it goes to the right, and x will always be going to negative infinity as it goes to the left. So these are the constants. Those will always stay the same. But what are my y values doing? What are they approaching? All right, so by the way, this little arrow here means approaches. So you don't have to write the word approaches. So as y value, what are my y values approaching as x goes to negative infinity? What it looks like they're getting close to what number? Looks like they're getting close to 0. And over here, as my x values are traveling, what's happening to my y values as well? They're getting close to 0. And that's your end behavior, that's your right end behavior and your left end behavior for what's called the parent function for all rational functions. Yeah, right there. Okay. All right, so let's take a look at some other functions, and maybe end behavior will make a little bit more sense. So what if we said just a linear function, which is just what? Y equals x. Okay, so if I did this end behavior, that's just y equals x. As x is going to positive infinity, what is f of x? No, as x is going to the right, like what's happening? It's going up, so it's going to positive infinity. Well, as x travels or approaches negative infinity, as x is going to the left, what's happening to it? It's going down, so that's where f of x would approach negative infinity. So what do we call this? This is the right end behavior, and this is the left end behavior. Okay, you don't have to write all this down. If you want to make a quick little sketch, you can. Or if you just want to watch and see if you understand the concept, you can just watch and see if you understand the concept. Okay. What about quadratics? It's y equals what? X squared. Okay. So let's look at the right side. Ready? Let's look at the right side. Let's look at the left side. What's happening on the right? X is approaching positive infinity. What's happening on the left? X is approaching negative infinity. But what is f of x approaching? You're right, infinity. And what's f of x approaching on the left-hand side? Positive infinity. So no matter if it's going to the right or to the left, what's happening with the end behavior? It's going up forever to the left and up forever to the right. Back either way, it goes forever to infinity, left or right. Okay? Okay, wait a second. What if you did this? Well, let's look at the right-hand side. Let's look at the left-hand side. X is still going to the right, but what's happening to my y values? Thank you. They're going to negative infinity. And over here, what's happening to my x values? They're going to the correct. They're both going to negative infinity. All right. Okay. One more example. See if this makes sense to y'all. You're gonna be having to understand this concept in the Khan Academy. Yes. All right. Ooh, x cubed. Interesting. We got left in behavior and we have right in behavior. As x approaches positive infinity, what does f of x approach? All right. As x goes to the left or goes to negative infinity, where does f of x, where does the y values travel? Negative infinity. Because the x values going this direction are going to negative infinity, and the x values in this direction are going to positive. Well, understand this just means approaches. Just means the x is approaching negative infinity, y is approaching negative infinity. But if I put a negative sign there, now left and right, this when we're done, okay? Where is x going on the left-hand side? Negative. But where are my y values traveling? Aha. X approaches positive infinity, f of x approaches negative infinity because it's going down from left to right. So that's called end behavior, everybody. So what we're going to do is we're going to look at the Khan Academy, and we're going to show you guys how to look at end behavior in tables as well as in graphs. Okay? All right, so there are different rules that you need to understand when you're dealing with end behavior of what's called rational functions. Okay, so I'm going to write this down nice and neat. Maybe you can write it down with me, and then you guys will have a better understanding of what you are looking for. I'll show you the long way, and then I'll show you the shortcut and see if you like the shortcut or if you don't like the shortcut. Okay, so here we go. There's your function. Just write it down. Hopefully I wrote it down slowly enough for you to be able to write things down. If you're doing your own problem and not paying attention to me, well, that's your own fill-in-the-blank fault, and I will have no mercy on you. All right, so does everybody see this highest power right there? And this highest power right there? Okay, so you need to really pay attention to these powers, okay? Would you guys agree that 3 is greater than the number 2? If this power is greater than this power, then there are not going to be any horizontal asymptotes. And you're like, what the heck is a horizontal asymptote? We're going to be talking about that. So there are rules for horizontal asymptotes, and that's going to help us understand the concept. So real quick, let me show you guys what a horizontal asymptote is. I'll describe it real quick. And on your marks, get set, just go back to the very first one. This right here, everybody. I'll change colors. Do you see this line I'm drawing right there? I call that baby a horizontal asymptote at y equals 0. I'll call it HA. Ha! For short. Call it a horizontal asymptote. Do you guys know what we call lines that are vertical and are asymptotes? Vertical asymptotes. So we have a vertical asymptote right here. I'll spell it one time. Vertical asymptote. Got to be aware of them. They're out there in the world. Asymptotes, that is. All right, now look what happens. If I make x equals 0, isn't that a bad number to put into the denominator? Because we can never divide anything by 0. And that's, by the way, that's how an asymptote that's vertical is created, is when you make the denominator equal to 0. Okay? So we have a vertical asymptote running up and down. That's x equals 0. And we have a horizontal asymptote, y equals 0. So we're going to go over those rules right now. So one of the rules is this. And this is what I want you guys to write down in your journal. Rules for horizontal asymptotes. Whenever you guys pronounce the word asymptote, make sure you get through it quickly. Don't hold on to the first syllable too long. Otherwise, you might get into trouble. All right. All right, so here we go. Put f of x equals a times x to the power of m plus I don't care over b times x to the power of n plus I don't care. So it doesn't matter how long or ridiculous it is. It's just we're just focusing on the very beginning, the m and the n values. And the number one thing I said was if m is greater than n, which is our case, because 3 is greater than 2, then there are no HAs, no horizontal asymptotes. Now there will be a slant asymptote because it's it's 1 degree higher, but we'll go over the rules for slant asymptotes, also known as oblique asymptotes later. Right now I just need to know there's no horizontal asymptote. Rule number 2. If m is less than n, which means if this power is less than this power, then you have a horizontal asymptote at y equals 0. Now what does that mean? I'll give you a quick little example, okay? What if I had a function that's a rational function and I had like x minus 2 over x squared plus 4? Then automatically you just look at it and go, hey, look, you're a 1, you're a 2, 1 is less than 2. Your end behavior is always approaching 0, just like our very first problem. To the left and to the right, it went to 0. Now, if you don't believe me, that's okay. I'll just show you real quick. X minus 2 over x squared plus 4. I just randomly chose that. So I'll put divided by, I said what? X minus 2 over x squared plus 4. Without even, I just made it up. Does everybody see how it gets close to 0 on either side? What if I change this to the power of 2, but I make this to the power of 3? Once again, it gets close to what? On left and right. It gets close to 0. What if I made that 5, but I made this a 10? What's it still get close to? 0. What about 6? Still 0. How about 7? Still 0. So what am I trying to tell you? If m is less than n, it's always going to be y equals 0. Okay, last scenario, number 3. This is the most important one. Put it in blue. Either m is greater, m is less. What's the final and the last scenario? Yes, m is equal to n. Then your horizontal asymptote is always the a value over the b value. And you're like, what does that mean? Check this out. I'm going to give you one example. Ready? Y equals, let's put negative 10 x squared minus 4x over 5x squared plus 3x. Are these powers the same? Ooh, what's my a value? Negative 10. What's my b value? 5. So this would be negative 10 over 5. So I would know my asymptote, that's a horizontal one, is y equals negative 2 without having to even like type it into Desmos or look at it. But I'm going to still prove it to you because I know I got some doubters out there. No, those are Thomas's, not Judas's. Thomas was the doubter. All right. You guys ready? I said what? Negative 10 x squared. What did I put at the end? Minus 4x. Just a random minus 4. Oh, hold on. Up top. Dadgummit. Minus 4x. Put the negative right there. Okay. And what did I say on the bottom? Was it 5x squared? Plus 3x? What did I say the asymptote was at? Y equals what? Do you see? Do you see how it gets close? Now check this out. Look what happens. What if I change that to a 12? Now it's going to be not negative 2. It's going to be negative 12 divided by 5. Okay? If I change this to 20, uh-oh, which is? Aha. See how we can just change it no matter what? Why? Because those powers are exactly the same. All right, so let's start looking at our end behavior now. Here's my shortcut, guys. Yeah. Okay, do you guys see all I wrote down there? All I wrote down was what? The highest powers. I took everything else away, I just focused on the highest power. So right now, what would, if I simplified that, what would that become? What's negative 8 divided by negative 2? Negative 4. What's x cubed divided by x squared? X. What does a negative 4x graph look like? It looks like a very, very, very steep line doing what? Going down from left to right. So what would you guys say my left end behavior? As it's going to negative infinity, what would this be going to? Positive infinity. And what about the right end behavior? As it's going to the right, what's happening? It's going. So that's what I'm going to choose without doing really any difficult math, because I can clearly see it's going to be doing this over time. Now, before I type this in, it's going to be positive, it's going to be negative. What I'd like you guys to do, for those of you who are like, you don't like that, could you please just type this in as it appears? Hopefully you wrote it down. We're going to type it in as it appears, and it should make sense. So I'm going to clear this out. You're going to have to help me out. Hopefully one person in my class wrote it down so it goes faster, versus, otherwise I'll go back and forth. It was negative 8x cubed, and then there was minus 3x plus 4. And then in the denominator, it was 2x squared minus 9. Okay? So there's your graph. But what I'd like you to do, though, is I'd like you to make a table. And we're going to type in a number that approaches negative infinity, like negative 10, and then negative 100, right? And then negative 1,000. What's happening to my y values as I'm doing this? But what's happening to my y values? They're getting positive, right? It's going up, so it's going to positive infinity. Well, what if I start with a 10, and then 100, and then 1,000, and then 10,000, and then 100,000? What's happening to my y values? They're going. That's a way you could do it in your table without having to do a whole bunch of complicated math. So as it's going, so what does this mean? So if you would please, in this problem, if you wanted to write just that down, you could say, what's happening to my x values? They're going to negative infinity, and my y values are going to positive. Here, my x values are going to positive, but my y values are going to negative. So positives go with positive, and negatives go with negatives. I'm trying to make it as easy as I can. Okay, so let's go back over here. So as my x values were going to negative, what was happening to my y values? They were going to positive, and as my x values were going positive, my y values were going negative, and that's it. Okay, now, yeah, here we go. Let's do another one. Okay, let's do the shortcut. You guys ready? What do I have here? I have 9x to the power of what? 5. What's the largest exponent there? 1x, right? So what would that simplify to? 9x to the power of 4. That graph would look something like this. It'd be really, 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 really narrow. So what's the left end and what's the right end? As x is going to the right, it's going to positive. X is going to the left, it's going to another what? Another positive, because it's going up and up. So my value is going to be positive and positive without doing any work. I'll do another one. Do you guys see the powers here? What are my powers? 4 and 5. Would you guys agree? 4 is less than 5. What did I always tell you about this number being less? What's it always going to be? Let's look at the next one. What do you guys see? That says what? Negative 8x cubed. What does that say? 2x cubed. Are these the same? What's negative 8 divided by 2? Negative 4. Remember, if they're the same, we take the a over the b. Without even looking, look. Oh, negative 4. Oh, negative 4. Please give me something hard. All right, last one. What does that say? 9x to the power of 4. What does that say? 3x. Would you agree that would be 3x cubed? What does a positive cubic function look like? That's a positive cubic function. Let's look at the left. Let's look at the right. What's the left in behavior? Where does it go? It goes down. What's the right in behavior do? It goes up. So as x goes to negative infinity, that goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. But I realize, guys, the shortcut's not for everybody. Okay? So how could you make sure that you get this right? I'll show you guys how you make sure that you get it right. We're going to type this in nice and neat. 9x to the power of 4. Got it. Going over here. Close that out. 9x to the power of 4. And then it was what? Was it minus 5x squared? Look. Minus x. And what's in the old denominator? 3x minus 7? Okay. 3x minus 7. So you could just type it in, guys, and you could hit edit and that. Okay? So let's check this out. You guys ready? Because would you guys agree just looking at the graph, it looks like everything goes what? Down forever, right? That's what it looks like. But let's just check. Negative 10 stays negative, stays negative, stays negative, stays negative. Let's go positive 10, okay? Holy cow. Positive 10 isn't negative, is it? It's positive. 100. What's happening as x's are getting bigger? What's happening? It's getting bigger. So what is this? So when you guys are interpreting this end behavior, my x values here are going to negative infinity. These are going to negative infinity. But here it's going to positive infinity. My y values are going to positive infinity. Well, let's put it this way. Like, why does the graph not show me? Watch. Check this out. Can you guys tell me what that says? 10 and what? 3,890. Would you guys agree that we cannot see 3,890 right there? We would have to zoom out. Oh, there it is. Way up there. But we can't see it when we're out here. We have to keep zooming out until we get to the thousands. Yeah, it's yeah, you can kind of see it going up, but yeah, it's harder. We could put our parameters. So check this out. What if we put our parameters like we went on the x-axis to, let's say, just 5 to 10. Okay, so 5 to 10, but we went to the y-axis. Ready? We went to the y-axis like 0 to. Hold on, let me see if I can delete this. Ready? So we can see it better. How about this? 10,000. Let's do step by 1,000. Can you guys now see the graph now that we've scaled it? Now, if you looked at this, would you guys agree that this is going towards positive infinity now that you can actually see the graph zoomed out? Yeah, but you couldn't see that if we did what? Home button. That's all you see. Okay? That's why I want you guys to use the table. Use the table and make your numbers go where? To positive infinity and negative infinity. See where the graph goes. All right? So, what does this mean for us? That means as it's going to negative infinity, the y values are also going to negative infinity. As this is going to positive infinity, what's happening to the y values? They're going to positive infinity. And that's how you do it. And have a good day.